Now I'm moving to question 5th. As you can see, I have already pasted the code. Now I have already created a file too. So this question requires a program that uses system input output calls to open a file, display its content, get user input to append that input, and then display the updated content, all using system input output calls. So let's do it. Mhm. Okay, so I have pasted the code. Let me explain this comprehensive program. I included all necessary headers, stdio.h for standard input output, fcntl for file control, and unistd for system calls and string for string operations. I create a helper function called displayFile that takes a file descriptor and displays the file content. In displayFile, I use SLC to rewind to the beginning of the file position 0 from C set. I read the file in 1024 byte chunks for efficiency and write directly to standard input using std out file in. In the main function, I open the file with ordwr o append flags. This means read write access with automatic appending. Okay, the O append flag is crucial. It ensures that all writes go to the end of the file even if multiple processes are writing simultaneously. I display the initial file content using our helper function. For user input, I use fgets with stdin to read a line of text. Notice I am mixing standard input output fgets with system input output. This is perfectly acceptable. I get the input length using the string string length, which is already a function in our string library, and then write it to the file using the write system call. Finally, I display the updated file content to show the append was successful, and all operation includes proper error checking. So now we are gonna save our file by Control plus X, Y, and then enter to confirm the file. So let's see if our file is created or not. Oh, q5.c. Okay, so let's display our code. Mhm. Okay, now let me display the source code. Yeah, the display file helper functions that handles file reading and display. Then our main function, the main function that orchestrates the entire workflow, and then the use of OAppend flag, which is essential for correct append behavior, and the mixing of input output, open, read, write, with standard input printf gets where appropriate, comprehensive error handling throughout. Yeah. Now we are gonna compile our program with the help of GCC. Let's create an executable file. Yeah. So then, okay. Sorry, it's my mistake. q5.c. Okay. Now we are gonna create a test file for this. So creating a test file. then initial line 1, initial line 2, initial line 3. We are doing this because we are gonna make it as our test file. So it's test file.txt. Original file content test file. We created 3 initial lines. Let me display. We can see the before and after states clearly. Okay. Now I'm going to demonstrate the append behavior. Let me demonstrate the append behavior first. Without append, writes would go to the current final position. With append, all writes automatically go to the end. The append flag is a key feature of this program. Without it, if we use lseek to move around in the file, our writes might overwrite existing content. With append, every write operation automatically goes to the end of the file, which is exactly what we want for an append operation. Let's run the file with automatic input. Running the file with automatic input. This is the ended text via system with output. Now, we run the program using a flag to provide automated input. This stimulates the user typing. This is the appended text via system input, output, and pressing enter. You can see the program first display the original file content, then shows the prompt for user input, receiver our automated input, finally displays the uploaded file content with the new append at the end. Verify the file was actually modified. File was actually modified. Get test file. Let me double check by displaying the file type. As you can see, the file contains our appending text set and confirming that the write operation successfully modified the file on the disk. Now I will demonstrate the interactive mode. I have created a new test file and I will run the program without automated input. This shows the program waiting for actual user input. Demonstrate the program works interactively. Line in, line B, test 5, interactive. Mm. Starting interactive demonstration, I will type in manually. This video is gonna be so long, so I'm gonna break it into two parts. Okay. When program waits for input types, this is interactive input, then press enter. Okay. This is interactive input. Mm. You can see the program works the same in interactive mode. It displays the file, waits for user input, appends it, and shows the updated content. Now, let me explain input output features. Let me highlight the key system input output feature used. GRP and open. Mhm. Let me point out the key system input output feature in this program. Open with O add WR open for read write access with automatic opening. I'll seek to rewind to the beginning for display. Read with 1024 byte buffer for efficient reading, and write with std out file to write directly to standard input. These are all low-level system calls that give us precise control over file operation. Testing, error, handling, 80 to 5 non-existent file text. There's a mistake again. Okay, that's it for